This is lesson 5-3, slope-intercept form. A couple of definitions that we need to discuss as we move forward. The slope-intercept form of a linear function refers to one of the three ways that we express a linear function. Slope-intercept form is the form that we want to use when we are graphing linear functions on a set of axes called the coordinate plane. Slope-intercept form is something you're very familiar with. It is y equals mx plus b. In this form, y and x stay as is. You keep them as y and x. M is your slope because it's how we move. B is the y value of the y-intercept because it is where we begin to plot points for graphing a line. Here's some examples to take care of. Find the slope and y-intercept of each of these equations. Pause the video at this point to give yourself a chance to try it on your own. So for the first one, the slope, m, again, is the number that's in front of the x, that's equal to -2. And the b, in this case, the y-intercept, is going to be 7. Now, writing it as a point, it would be 0, 7. The 7 is what we're concerned with at this point because it's what will be used to graph functions. With y equal to -9, I can actually rewrite this equation as y equals 0x minus 9, which means that your slope is equal to 0, and your y-intercept, your b, is going to be -9. Here's another example. Write an equation of a line with the given slope m and the y-intercept b. Pause the video at this point to give yourself a chance to try it on your own. So again, the slope-intercept form is y equals mx plus b. The -5 goes in the m spot. The -6 goes in the b spot. We end up with y equals -5x minus 6. Here's some more examples. Let's write an equation in slope-intercept form of the line below. Pause the video at this point to give yourself a chance to try it on your own. So what we need to look for with slope-intercept form is we need to look for the slope and the y-intercept. The easy one to find is the y-intercept. It's where it crosses the y-axis. Right here, where I'm marking a dot, is your y-intercept. That's at the point 0, 1. That would mean my b is equal to 1. Now the slope, remember that slope is the difference, the change in y over the change in x. We've talked about that. So what is the change in y? As we go from this point here to this point here, I'm going up 2 units in the y direction, and I'm going +1 in the x direction. That would make my slope 2 over 1, which is equal to 2. So writing an equation in slope-intercept form here would be y equals 2x plus 1. Here's another example. Write an equation in slope-intercept form that passes through the given points below. Pause the video at this point to give yourself a chance to try it on your own. For this, since we have the 2 points, we can find the slope. Remember our slope formula of y2 minus y1 over x2 minus x1. I'll call this point P1 and I'll call this point P2. So my y2 is 0, my y1 is 2. My x2 is 0, and my x1 is -1. 0 minus 2 gives me a -2. 0 minus -1 gives me a +1, so my slope is equal to -2. Notice that my second point has an x value of 0, which means that is the y-intercept. So the y value is also 0, therefore my equation is y equals -2x. Let's talk about graphing lines using the slope-intercept form. First thing you want to do is put the function into slope-intercept form. meaning that we want to solve for y. Next, if your slope isn't already in fraction form, you need to do so. Typically, if it's not in fraction form, that means it's an integer. You could put any integer over 1. Next, plot the y-intercept, or your b, on the graph, followed by moving using your slope to determine the other points. Finally, connect the dots. Make sure you put arrowheads on the line, and lines should be drawn from one edge of the graph to the other. Let's take a look at an example. Make sure you're always writing the function on the line. My apologies for missing that last step. Here's an example. Let's graph this equation. This will be a guided example as I'll do it with you. So pause the video at this point to set up your graph and set up your equation. So the first thing I want to do is get y by itself. I'm going to divide both sides by 3. Now remember that this 3 now belongs here and here. So what I have is y equals 2/3 x minus 6 over 3. Now, I can simplify 6 over 3 because it's nice and pretty. That'll be y equals 2/3 x minus 2. My slope in this case is 2/3, so I don't have to change it at all. My b is -2. Now I'll go on to my graph and I'll plot my y-intercept at -2. Now I want to move with my slope. Remember that slope is the change in y over the change in x. So 2 over 3 means that I want to change the y direction by 2 and change the x direction by 3 before I plot another point. So my second point will be going up 2 and over 3, and I'll plot another point. I'll do up 2 and over 3 again, plot another point. Up 2 and over 3 again, plot another point. I plot as many points as I can on the graph. Now, it's about connecting the dots. You should be using a ruler or a straight edge for such things. I have a difficult time with the technology doing that. Arrowheads on each end of the line, and you're writing the original function on the line. So 3y equals 2x minus 6. If you're having any issues in any portion of this lesson, please make sure you are emailing me or consulting me in class.